Okay, got it. All right, a very good afternoon. Good to see all of you over here. All right, welcome to the Environmental and Water Tech webcast today. It's going to be happening from 4:30 all the way to 5 p.m. All right, good to see all you guys, mother and daughter from Woodlands, right? Woodlands and from, where are you from? Sorry, and Hugh Grove. Very good to see you guys and some of the other students, right, that we just have a chat just now. Right, fantastic. Good to see all of you. Right, can everybody just give me a smile? All right. Okay. Great. Excellent. Okay. Nice. Okay. So just relax now. Okay. So you may be looking at something that is a little bit complex looking, but it's pretty easy to set up, right? Because I have already set up about 50% of it. So there's about 50% more that you need to do later on. Okay. And I guarantee you, there's no grading. Okay. All right. So it's pretty simple, right? It's not a test of your ability to connect stuff, right? I'll give you some instruction, and then we can move along with their project later. Okay, so some of you over here may be asking, hey, what exactly is EWT, right? And then who exactly am I, right? So I'm a lecturer with the School of Life Sciences and Chemical Technology, right? And I'm with this course, right? The EWT, the Environmental and Water Tech Diploma. All right, so just a little bit more about myself, right? So I'm an innovator. I'm a solution architect. I'm an integrator. I'm also a sailor. I sail a lot. I'm still sailing, right? And I am actually an unmanned aircraft pilot license holder. So I can actually conduct commercial work, right? For consultancy project, I can teach my students. I can even qualify them to be a manned aircraft pilot as well. I also run a drone school, by the way. Okay, so I'm just one of the many lecturers in the School of Life Sciences that has all these interesting hobbies and interests, right? So if you do come and join us at Nanyang Polytechnic, School of Life Sciences and Chemical Technology, you probably meet another lecturers that I think will be awesomely interesting. All right. Okay, so, when students come to the School of Life Sciences and Chemical Technology, we always pose them an interesting question. If you could make the world a better place, what is the one thing that you would do, actually? What would you do? If there's one thing that, you can make the world a better place, what would you do? Not too sure yet, right? Don't worry, okay, you come over here, we'll give you some idea how to do it. Later on, I'll share some ideas as well. How about you? Not sure as well, right? Right, how about you? Not sure, right? Sorry? Okay, get people to talk out their differences. How about mommy? Okay, mommy wants to have more inclusive community. All right, cool. You guys? Free what? Free sanitary napkins. Thank you. All right, that is a brand. Okay, so I can't mention the brand, yeah, but I hear you. How about yourself? Save life. Okay, save life. Thank you. Awareness to climate change. Thank you very much. Yourself? Charity work. Great. Okay, I see that you're going to work for me soon for free. Thank you very much. Okay, and you? Not very sure at the moment. And yourself? Okay, awareness of climate change. Okay, great. All right, thank you so much. Okay, and of course, at the School of Life Science and Chemical Technology, EWT, one of the things that we teach our students actually is to work on things like water pollution, right? It's always a problem around the world. Okay, that's one thing that we do. And one of the way of doing that is really, to teach our students how to produce clean drinking water, right? Singapore happened to be a place where good quality drinking water, right, is everywhere, right? You can just turn on the tap and you can drink it. Okay, ask any army boys, right? Their source of water is from the tap. It's never boiled. There's no further chemical added, and just turn on the facade, and the next thing you have is a clean bottle of water. Okay, and our student from EWT actually does that, and most of them, you'll find them working at PUB, right? Our water agency in Singapore. So quite amazing, right? The second thing we do actually is to look at, designing sustainable water supply. Some of you talking about climate change. Now, how do we then produce water, right, that is sustainable? Now, production of water requires an energy source, right? How do we make that even more sustainable in that sense? So we also teach our students to make clean drinking water in a more sustainable way, right? Either using solar power or other form of renewable energy. And that is what we are doing right now in Singapore. Right, but before we go on, I also want to introduce you my student assistant, right, who is also my final year project student working on the AI project. And right over there, you have Ryan, right? So that's Ryan. So Ryan will be giving all of us a hand later on, right? So if you have any problem, just raise your hand and Ryan will be there, right? So he has done internship already, okay, on environmental impact assessment. Am I correct? Okay. And now he's working on my project for the final year project, or what we call the environmental innovation research. So I have invited him and he has gladly joined us. In fact, he has been working since the morning for us as well. So thanks, Ryan. Okay, so going forward, you may ask, what else do we look at? Okay, so for EWT, we start looking at water technology, we look at resource conservation, we look at pollution control, for example, solid waste management. We also look at waste management as well. So these are the 4 key areas that the EWT looks into, okay? And a bonus fact for all of you, okay? Students who take our diploma will graduate with 3 workforce qualification, skill for an additional career boost. So there are additional qualification upon graduation, okay? And one of it is the noise monitoring certification, right? So you can join NEA, right? And you can straight away practice that already. Okay, and of course, okay, together with PUB, we collaborate with PUB, and PUB has given us this bond-free scholarship, okay, a bond-free scholarship. And during internship, we actually work at PUB as well, all right? So they're very generous with the bond, and it's absolutely bond-free, okay? And you may ask, hey, so it's bond-free, then what happened after that? Absolutely nothing, okay? But the facts tells us that our student continues to work with them, all right, because they provide a very good career pathway, right? And the mentors, the bosses are all very nurturing. Okay, so that's something you can consider if you are taking the diploma in environmental and water technology. Okay, some of the other things that we do as well, we do a lot of projects. You can see on the right-hand side over here, these are our students. I think they graduated last year. They were using the drone operation for environmental monitoring and impact assessment. So we've been using one of these drones over here, right? And the students how to control them as well, right? We also teach our students how to use the drone for environmental monitoring. We also send our student for competition. So this is Rain, right? She was the grand champion, right, against the competitors from Germany, from Japan, and she emerged winner last year. Okay, so that's Rain. And we also send our student for internship to PUB, to Sembcorp, right, to DuPont, and many, many more great organizations. And then you think about it, right? What else do we not do? Actually, we do a lot of stuff, right? One of the things we also do a lot is actually we turn ideas into impact. Okay, for example, like I mentioned before, we actually use drone to, and artificial intelligence to do environmental monitoring to see what has changed after certain work has been done to the environment. Okay, we also actually work with a third-party company on rat population control in housing estate. Right, I'm sure you have seen your fair share of rats appearing in shopping center. Am I correct or not? Right, and almost everywhere. Right, Singapore is a food heaven. It's a food paradise where you find food, there is plenty of rat to go around. Okay, and it's a problem that will never go away, whether in Singapore or in other parts of the world. Right, so we actually use remote sensing. We use thermal sensor. You might see some sensor later on, and also automatic delivery of the rodenticide. So we does that as well. We also work on tracking mosquitoes. You might have seen one of these before. This is what we call a gravity trap, right? You might find it in the condo, the HDB landed property, right? That there are actually 70,000 of them across Singapore, right? The only trouble is that it's very manpower intensive. You need to get in there and count the mosquito on your own. So what we did is that we use camera system. We have an app as well, and we look at the mosquito remotely, and we can count them remotely as well, without having the humans go down and start counting it. So this is one of the projects that my student did. And one last impactful project that my student is doing right now is looking at secondhand cigarette smoke mapping. Some of you may experience having smoke coming into your house from neighbor who smoke, right? And trust me, there's nothing you can do about it, right? Because they are smoking in their own confined spaces, and it happens that the wind came and the secondhand cigarette smoke drift into your house. So what we're trying to do right now is to do this smart count mapping of the secondhand cigarette smoke in housing estate. Pretty cool, isn't it? Pretty cool, huh? Okay. And these are all IoT related projects. Something that we thought is absolutely important for our students. Okay, so I'm going to show you very quickly some of the AI that we did. Okay. So what happened is that the student is flying the drone, okay, and as the drone goes through, is able to detect the rubbish that is thrown on the ground, and is able to count the number of trash that is thrown, all over the place. And this was the pest detection I was talking about. We could actually count the rat. Can you see that? Yeah, so these are all done by our student actually, and I think Ryan is one of them doing that, the rat as well. All right, yeah, okay, good. Okay, so you could be the innovator the world is waiting for, right? So at LSCT, right, we produce innovators, right, besides helping you to gain the domain knowledge, okay? And well, right now we're going to, build some more skill with EWT, a very quick flavor of what you're about to do, right? And this is one of the things that we do in one of our modules as well. Okay, but before that, we are doing this because we want to stay relevant, correct or not? And as you know, right now, we are in the age of Industry 4.0, am I correct or not? Okay, 4.0, right? So previously, we started, back in 1784, we started with Industry 1.0. Then we moved on. In 1870, we went on to Industry 2.0, where we have a lot of mass production, am I correct or not? Okay, and then in 1969, we go on to Industry 3.0, okay, where we have automation, computers, and electronics. And then now, okay, the era that all of us are in, okay, is called Industry 4.0, okay, where we have cyber and physical system combined together. They give us greater awareness and greater response time, okay? And some of the things that you will hear are like Internet of Things, in short, IoT, which you're going to do something about that today as well, okay? And networking, all the sensors that you have in the system, in the factories, in the environment, in your neighborhood, in your home as well, a lot of home automation. Okay, so that is the era of Industry 4.0. Okay, and what we're going to do today is going to be relevant to you after graduation. So upon graduation, right, you have some skill set, you have some understanding, okay, about Industry 4.0 and how that can be plugged into what we are trying to do. Okay, in our case, we are talking about producing clean water sustainably. We are talking about waste management. We're talking about controlling air pollution, okay, and so on and so forth. Okay, how then do we use IoT? How then do we use the power and the technology of Industry 4.0 to make that even better? Okay, so take for example, okay, this is actually an example, right, of where we live, how we live, and what we do on a regular basis, correct? Okay, so probably we live somewhere around here where there's this building. Of course, we don't have any power station over here, right? We don't have such a big bridge, but yeah, we have a coastline and so on and so forth. But where do you think our technology, our IoT technology, our environmental technology can be plugged in? Okay, so there's a few. So I'm going to show you exactly. So we can actually use this kind of technology to detect leakage, for example, right? Singapore is a water scarce country, right? We do not have enough water because we do not have storage space for water, right? It depends on what comes in, right? And we use them almost immediately, right? So Singapore is known as a water scarce city. We don't have enough water. Okay, so we need to make sure that water don't leak. So we have water leakage. We have waste management, for example, right? We know when when our bins are full, when we need to move the trash from point A to point B, right? Very, very effectively using all the smart technology. We actually measure the water quality on the fly in the water production factory, in our treatment plant. We can monitor them on the fly, right? And these are all connected, okay? These are all networked together. We can map noise as well in our urban environment. Singapore has a lot of construction going on, isn't it? And we are always productive, right? There isn't a time where you don't hear construction, honestly speaking, except at night after 7 o'clock. Okay, but how about the rest of the time? Okay, there's a lot of noise going on. So we do a lot of noise mapping, okay, and that's what EWT do as well, right? And that's why after graduation, you actually have a certification to do noise mapping. All right. Of course, if there's a forest fire in Singapore, we can do that as well because of all the sensors that we know how to work on. And of course, we can also measure, monitor, detect air pollution. All right. Yeah, so there are many, many things that we can do, okay, as part of the EWT diploma. Okay, plenty of career that you can venture into, plenty of application that you can think about. Okay, so now let's talk about the hardware they are given to you. Can you see on your table there is a collection of items? Am I correct or not? Right, so let's go through some of them. Let's go through some of the hardware. First thing first, do you see that you are given a very interesting looking piece of component? Right, can you see this? Okay, so this thing is actually right on your table, actually. Can you see? There's actually this piece over here. Can you see this piece over here? Okay, so that is what we call the microcontroller. It has a processor in there. Can you imagine it's so small? Okay, and this is not the smallest I've ever seen. It can be shrunk down almost 10 times. Okay, so this is the bigger version that we have, and of course the cheapest version that we can use, right, effectively, all right, in case they break. So this is called a microcontroller. Now, I've been mentioning about IoT, right, Internet of Things. That means this controller needs to be connected to the internet. Am I correct? Now, can someone point out to me, raise up your hand, point out to me, which part of this allow this controller to be connected to the internet? Anybody? It's right there. Look for a 4-letter word. Okay. Can anybody see? Sorry? Say louder. Wi-Fi. Thank you. Do you spot the word down there? Wi-Fi, right? So there is actually a chip in there that allows you to connect to the internet, just like your handphone connecting to the internet, right? And yep, it has the same chip that you have in your phone, just that the chip in your phone is so much more smaller. Okay, so you have one over here, and if you look at this, there's a few pins going all around. Okay, this is where the connection takes place. Okay, later on I'll show you a bit more. You also find that you have a little nice LED light here. Can you see? Can you see the LED light? Can you point to the LED light for me, please? Thank you very much. Right, thank you, thank you. Some got green ones, some got red ones, some got yellow, right? Orange. Am I correct or not? So you see the LED lights? Great, huh? Great, okay. Now, as you are looking at the component, do not attempt to plug them out. Because if you plug them out, it's fine, but you gotta put it back again. Okay, right? You can plug them out, but you have to put it back again. But I'll show you how. Okay, you have see little light here, and on the board that you have, you might find something a little bit bluish in color. Can anybody guess what exactly this might be? Blue in color. What do you think this is? Remember, we are an environmental course. So what do you think we'll measure today? It's a sensor. What do you think this is? What does this measure? What do you think? Air quality. Wow, good. Okay, what kind of air quality are we measuring? Huh? Humidity. Good. Okay, so we are going to measure humidity. So later on, you're going to tell me what is the humidity in the room. Now, besides humidity, what else do you think we are measuring? CO2? No, not CO2, anything else. So you measure humidity, one more item. Come, you guys, guess. Sorry? Oxygen. Wow, I wish I can. Okay, but is there a sensor for oxygen? Yes, there is. Okay, I'm going to give it to you. Okay, it's going to measure the temperature. Okay, so we're going to figure out the humidity and temperature in this room. All right, so this is actually a humidity and temperature sensor. Excellent, good guess, guys. And then on your board, you also see you have something like this. Can you see something like this? What do you think this is? Sorry? Well done, all right. So this is the display. What do you think is going to display later on? What's that? What's that? Is it something? The reading, right? Excellent. What kind of reading? The numbers, great. What kind of numbers? Temperature and humidity. Thank you so much, right? So it's going to show you the reading, right? And the reading tells you the temperature as well as the humidity. Okay, so great. You have a few of these components. Now, what else do you see? Of course, you see something like this. Am I right or not? Okay, you see something like this. What exactly do we call them? We call them breadboard. Okay, this is called a breadboard. Okay, so it's for you to do quick prototyping without having you to do any soldering. Soldering meaning you need heat, right, and a solder or flux in order to join the wires together. So you do not need that. So you have what we call a breadboard. It has many holes. Am I correct or not? Okay, and obviously if there's so many holes, and of course, sorry, before that, breadboard also come in different kind. You have the, the long bread, right? This is called a French loaf, right? A French loaf because it's very long. Okay, right, and then of course you have the smaller one as well. Okay, these are the mini tarts. Okay, I'm just kidding. All right, so you have a big breadboard, and of course you have a smaller breadboard. Okay, and of course, looking at the breadboard, you see there's a lot of hole, and on the breadboard you see that there is two interesting color over there. Can someone tell me what are the two interesting color? Red and blue, right? So you see red and you see blue, right? What does red represent? Positive, thank you. And what does blue represent? Negative. Well done. All right, so you realize that it's labeled for you. That means you can actually connect your wires. All right, positive or negative, right? Wires. And with negative and positive wires, you will also come together with wires or cable. Am I correct or not? Can you see that you have a whole array of different colored wires, right? And that is where your power will flow through. Am I right? Okay, great. Okay, so now we identify all the components inside our, on the table, in front of you. Okay, and of course, we might forget something. You might find something like this. What do you think that is? Charger. No, this is not a charger. Make it longer. Charging cable. Very good. Okay, it's like a game show, right? Yeah, charger, charging cable, so longer. So you find a charging cable. All right, some of you may be getting the white one, some of you may be getting the orange one, some of you may be getting the black one, right? So it's an assortment of charging cable. All right, and of course, last but not least, you have a very interesting item that I want to pass to you, right? Could you give me a hand and pass it to them, please? Okay, so just pass one to each set, please, if you may. You can get the whole thing. Thank you. All right, thanks, Ryan. Okay, so we talk about the sensor already as Ryan is passing around. You have the sensor, you have some of the components. There are different sensors as well. You have the temperature sensors, the light, the humidity, and a whole array of different sensors, yeah? You even have sensors, right, that can measure your heart rate, right? Just like the one you have on your iPhone, okay? But we're not going to go to the heart rate today. You have motors as well. You can remotely control your device to move on its own, right? And of course, we have all the different modules. We can actually put a GPS sensor on it. We can tag, right, any items on Earth with GPS, with a GPS module, right? We can put in a Bluetooth module as well. And of course, today you saw that I've given you the LCD display panel, right? Not all of you have one. Some of you have a bigger one, right? Some of you have a smaller one as well. Okay, and of course, we have this, which I've shown you, and all of you have discovered that it's actually a Wi-Fi chip given to you. Okay, so when we talk about IoT, right, not only do we want the sensor to display, to collect the data, right, we also want it to display on the LCD, correct or not? Now, are you always going to be with the sensor or with the device? Actually, no, you won't be, right? You want to remotely control and view the data somewhere in your comfort, correct or not? In the house, in the toilet, right, somewhere, during a meeting, you know that things are happening and the data are doing very well. Okay, so your data can actually be transferred or sent to the cloud. And this is one of the cloud that we use. We can actually monitor the humidity, the temperature, right? We can even actually look at the smoke sensors, right? And the number of time that the data was taken, right? In this case, I was working with one of the client. I think it was at one of the farm, and we were trying to measure some of this remotely, right? Without me having to travel all the way to Lim Chu Kang. I mean, MP, I can see all this. Cool, isn't it? All right, really cool. All I expect my client to do is to give me a broadband connection, okay, and a wireless connection over at their place, which is pretty simple actually. Okay, and today we will have a chance to practice that. Okay. Okay, and this is another example. Okay, and the best thing is, if anything weird happen, okay, you will send a message to my SMS. So I have SMS message. I also have a email notification as well. So everything is at the tip of my finger. So very amazing. All right, we can do waste management monitoring. We can do air pollution monitoring. Right, we can do water quality monitoring. Amazing. Okay, and this is something that we are doing right now as part of Industry 4.0. Okay, so let's build something. Are you ready? Great, huh? Excellent. Okay, so we got a good 10 minutes for us to build something, and I hope all of you are excited for it. Huh? Okay, so there's only 4 things you need to do. 4 things only, unless you have taken out all the cables. Anybody have taken out all the cables yet? Yeah, nobody, right? Okay, great. Okay, so first thing first, right? You do realize that this cable is taken out. Am I correct now? Now, I want you, right, to connect this micro USB cable, okay, to a connector on your microcontroller board. Okay. Now, how are you going to do that? I want you to scrutinize this microcontroller board and look for a connector that you think will fit the micro USB cable. Can you see? Can you try and do that right now? I'll give you 30 seconds and try doing that. If not, you can raise your hand. Ryan and myself will just come straight to you. Are you done with that? Excellent. Great. Don't plug in first. Follow my instruction now. Don't plug anything first, except that. Follow my instruction. Don't plug anything yet. Great. Excellent. So that's the first thing I need to do. Have you done it? Great, pretty easy, right? It's like charging a handphone. Am I correct or not? Excellent. Okay. Now, second thing I need to do, okay, is to look for this blue color air quality sensor. Okay, all of you show me your sensor, please. Everybody, come on, show me, show me. Okay, great, excellent, excellent. Okay, great. Now, I want you to face this towards yourself. The blue color should be facing you. Great. Okay, now I want you to put very close to your eyes and tell me what you see next to the 3-pin. There's a 3-pin over here. Can you tell me what exactly do you see? Anybody? There's some writing over there. I know it's pretty small. VCC, very good. What else? Okay, DAT, and what else? GND, well done. All right, so what is DAT? Data, very good. What is VCC? Voltage, all right, or power. And what is GND? Ground, very good. Okay, ground. Okay, so when you power something, right, you need a positive, wiring, and you need a negative wiring, right? And that's ground, all right. So that the power can flow through. And most importantly, okay, in between the ground and the power, you have DAT, which is data. And that is that cable that's going to transmit the data back into your microcontroller. So with that knowledge, okay, I want you to now take a look at your board. Okay, if you look at your board, there are 3 cables. Okay, that is red, white, and black. Okay, the red color represents VCC. The white cable represents data, DAT, and the black cable represents ground. Right? I want you to again take the sensor face towards yourself and try to align it and plug it onto the breadboard without taking out anything. Okay, so I can give a hand. Maybe Ryan, we can give him a hand. So can you see? It's red. This is white and this is black, right? So we can just plug it in here. Okay, now you try and plug it in. Come. Okay, so you can see here red, white, and black. Then you can just plug it in here. Sure. You try, huh? Okay, try it first, huh? Okay, do not power up anything, okay? Do not power up anything yet. You guys good? Yep. Yes. Okay, good. You guys have easiest speed. Good job. You guys? Okay, you have to plug anything. Okay, so can you see that that's red? Okay, so instead of a white, right now you got an orange and then you have a black one. So you just need to plug in here.
Oh, okay.
Okay, you just align that. Sorry. Yeah, okay, so you can see I can plug in here.
Oh,
okay, go for it. Okay, once you're done, raise your hand and I can do a quick check. You're good? Excellent. Very good. Okay, very good. Okay, good. You? Well done. Okay, perfect. Excellent. Okay, Ernest is working on that. How about you? Lace is doing? Yay. Red. Black. Okay, good. Well done. Good job. Okay, you guys are good. Ernest, you okay on that? Should I do a quick check again? Great. Looks good. Looks good. Looks good. Okay, one black and yes, you got it. Well done. Okay, so next step, the third one I need you to do is to connect up your LCD display. All right, so most of your LCD display has 2 cables that's not connected. One is yellow and one is green or orange. Okay, or your case is special. All right, it's reserved for the mother and daughter's team. Okay, it's a brown and white cable, right? It's a brown and white cable. Okay, so great. So brown, you should be going to D1. Okay, D1. Can you see there's a D1 on your microcontroller? Right. Okay, so those with the yellow cable, right, plug the yellow cable to the D1 output. Delta 1 on the microcontroller. Can you see D1 on the microcontroller? Plug into the the breadboard. Yes, right. D1 is here. Can you see D1? So this is the board, right? Good. Excellent. Okay, great. Yellow is done. How about you? Can you see the D1 here? Oh, D1 is here. So that's right. That's right. Yes. Good job. D1, right? Okay, good. You guys okay? Yeah, D1. Well done. Doesn't matter. It's for you to take note when you do annotation, but no need. Yeah. How about you, ladies? Okay, yellow go to D1. Good. Good eyesight. You guys got it? Excellent. Great. Okay. Now, how about the other cable? All right. The green cable, where does it go to? You guess it, huh? It goes to D2. Delta 2. Okay. Now, D doesn't it doesn't mean anything, okay? It means digital. It's not durian, all right? It's not durian, okay? Or D1 or D2. I know that's the grading of the durian, right? But D represents the digital output. Okay, so I see that most people have done it already. How about you guys? Yeah, okay, good. Okay, so you have, okay, good. Done, you're almost done already. Okay, good. Okay, so you have completed the third step. Well done, okay? You have completed the third step already. Okay, and the last thing you need to do, what do you think is the last step you need to do? Okay, thank you so much, is to connect the power bank. Okay, so the last thing you want to do is to connect the power bank. Okay, can all of you help me connect the power bank right now? Okay, try and connect the power bank right now. And tell me what exactly you see. You see blue screen, right? Okay, good. That's the answer I want to hear. Blue screen, right? Okay, blue screen, very good. Okay, how about you guys? Do you see anything? Okay, all looking at blue screen, right? Great. Excellent. Okay, all of you are seeing blue screen. Do you see blue screen over there? Good. Nothing on your screen, right? Nothing on your screen, right? Nothing on your screen. Nothing on your screen, correct or not? You know why not? Because it is not connected to the internet at the moment. Okay, so in order for that to start reading, I'm going to offer you something for free, absolutely. My personal hotspot. Okay? Then your next question is, where do I type in the password? Okay? Now, everything has been pre-programmed for you in this case, right? I re-enter my password. I also enter my SSID. So what I'm going to do right now, I am going to turn on my personal hotspot. And can all of you do me a favor? Unplug your power bank and plug in again. And tell me what you see. Unplug the power bank and then plug in again, okay? And that will allow your device to connect to my personal hotspot, and then the data will start flowing. The data for the data will start flowing, okay? What do you see right now? Do you still see a blue screen? Still see blue screen now? Okay. Oh, with text, okay. Okay, thank you so much. All right. Okay, so I think all of you should be able to connect right now. Is it okay? Doing okay? Good. Okay, what do you see? What do you see? What do you see on the screen right now? Can someone tell me? The date, right? What's today's date? 5 Jan. What's the time now? 5:02. That means we're about to end soon. Very good. Okay, 5:02. And what else do you see? Sorry? Humidity and? Okay, can someone shout to me and tell me what exactly is the humidity right now in this time here, in this place here? So that? 72%. How about you? 69. Anybody else? 69, 72, 63, 67. Sorry? 73. Okay, and? You guys? Nothing. Can't see very well, huh? Okay, because need to tune it a little bit. Okay, we can work on that. Okay, so you realize that actually there's one more step, right? We need to calibrate the sensor a bit more. Okay, but we are running out of time. Okay, so more or less you are able to gauge the humidity, the time, as well as the temperature, right? And to be honest, the device that's given to you does not know the time. The only way it knows its time, right, is when it is connected to the internet, which is through my personal hotspot. Okay, right? And of course, one last thing I want all of you to do is to do programming. Anybody keen for this right now? Yes, okay, you can stay behind, okay? But the rest of you, we can do this another day. Okay, so this is the programming we actually have to go through. Okay, we can do some simple programming. And trust me, these days, not many people do hardcore programming. What do? They actually use ChatGPT. And we do that as well, actually, in EWT, right? We can actually use ChatGPT and start to do the programming, right? So it saves our time, all right? Okay? So no worries if you do not know how to do the programming, because there's always Google and there's always ChatGPT, okay? So we are making all our students learn to be relevant and self-sufficient. All right. Oops, sorry. All right, so, and that's all I have for today. Okay, I hope all of you really enjoyed the program. All right, once again, we are EWT. And I want to share one piece of good news, right? We're doing another live class tomorrow, a webcast tomorrow for chemical and biomolecular engineering, right, at 1:30 p.m. tomorrow, Saturday. And in the afternoon at 4:30, same spot, same time, there will be another live class. This will be for the biomedical science, right? BMS, right? Diploma. They'll be doing that live class as well. If you cannot come down, don't worry. Hop on to our YouTube channel, right? The handle is MPLSCT. If you want to join us and follow us, go and find us on Facebook as well as Instagram, right? The handle is again MPLSCT. So with that, I'd like to thank all of you for your kind attention. And for those who want to hang around, stay behind, have more questions for me, I'll be hanging around here. If not, good day and have a wonderful week ahead. Thank you. Thank you very much. Oh, good. Thank you. Thank you for coming. Hope you guys enjoy.